Hello class, we're about to start lesson 9 from chapter 5. It's called Simplified Polynomials. We are going to do combining like terms and also simplifying polynomials. Now, with this here, we've actually covered this before as far as separating the terms and then combining them. We actually did this in lesson 6. So we're going to continue on with that. It's just that we have more variables and also higher exponents. That's what makes this a little bit more unique. Okay, so with that being said, if you notice here, when we have 7x squared plus 4x cubed, we know that because this is separated by addition, we have two terms here. And we know one term is 7x squared, the other term is 4x cubed. We notice with these variables, even though both of them are x's, because the exponents are different, we cannot combine them. So they must have the same variable and exponent in order for them to be combined. Now here they show another example of both of them having the x variable and taken to the second power. So since they have the same variable and exponent, they're like terms now. So you would add their coefficients, which will give 11. 7 plus 4 is 11, and carry over the x squared, or the variable. So now, with the simplified polynomials, it's basically the same thing here. We're going to combine the like terms and try and get it down to as small as it can be. So it's basically the same thing as combining like terms. All right, now we're going to move on to the next page. Okay, now it says for each pair of terms, indicate if they are like terms or unlike terms. Now again, you take each individual term. If they have variables, it must be the same variable, and the variable must have the same exponent for them to be like terms. If they have variables, but the variables are different, either by it being a different variable or by having a different exponent, then they are unlike terms. So I'm only going to do about 5 of these. So let's start off with problem number 1. Now when you look at 1, you have 4x cubed and also x cubed. Both of them have the same variable, same exponent, so they are like terms. So number 1 is like. Okay, the next problem. Let's look at problem number 5. We have negative 2x and 7x. Both of them have variables. Both of them are one term. Both has variables. And the variable is x. Both of them are taken to the same exponent. So this is like. And when I say they're the same exponent, you don't see an exponent with the x's, but they are assumed to be taken to the first power. Okay, next. Let's look at number 9. With number 9, we have negative 5m and negative 5m squared. Now you notice both of them have m, but one of them is taken to the first power and one of them is taken to the second power. So they are not like terms, they're unlike terms. Okay, now let's look at number 10. Number 10, we have x squared y and also xy squared. Now both of these have xy, but their exponents are different. The exponent for x is 2 here and 1 here. The exponent for y is 1 here and 2 here. So these are unlike terms. Okay, next I want to do, let's do 13. We have 14 times g and 1/3 times g. Now they have, both of them have the same variable, and both of them are taken to the same exponent. So they are like terms. Now, the last problem I want to do is 18. With 18, we add x squared, and then we add x squared over 2. Now, with this problem here, we must first separate this fraction here to see what it really looks like. So we still will have our x squared. Now, this fraction is really 1x squared over 2. And we can rewrite that as 1/2 times x squared. So this is really, this x squared over 2 is really 1/2 x squared. So now we look here. We both have the same variable, same exponent. So they are like terms. Okay, now, the next thing, we want to go down here to combine the like terms. Now I'm just going to do a few of these because we basically covered this before. So I'm just going to do a few just to give some examples of how this is supposed to be done. So now, let me start off with problem number 28. I'm going to do the excessively long ones first. Problem 28, we have g squared plus h squared minus 4g squared h squared plus g squared plus h squared minus 4. Okay, so we need to combine the like terms. Now, first thing we do here, let's look for all terms that just have g squared. So we had g squared here and g squared here. We don't pick this one because this is g squared and h squared. G squared plus g squared is 2g squared. Okay, so we have 2g squared. That took care of the g squareds. Now let's look for h squareds. We got h squared and we got h squared. A positive h squared and a positive h squared would give us a positive 2h squared. Because remember, it's assumed to be a 1 in front of these h's. So the h squareds simplify out. Now we have g squared h squared. It's only one of those. So we'll subtract 4g squared h squared. And then minus 4. Now, if we were to write this in its proper order, this is a correct answer. But in the back of the book, if you look at it, it's going to have a slightly different answer. It's going to start off with G for the letter of the alphabet. But GH comes before H. So we'll do minus 4G squared H squared plus 2H squared and then minus 4. And this is how you set it up from smallest to greatest. Okay, so now I'm just going to do 2 more problems and then we will be done with combining the like terms. And I think 32 and 33 are the best candidates here. So let me do 32. 32 is 9x squared y minus 3x squared y plus 4y squared minus 21 plus y squared minus 2. Now, if we look here, this 9x squared y and this negative 3x squared y, these are the only 2 like terms of the x squared y's. So this will leave us 6x squared y. Next, we have 4y squared and y squared. That will give us 5y squared. And then negative 21 minus 2 is a minus 23. So now this is our final answer. 6x squared y, 5y squared minus 23. Now we go to problem 33. We have 8x squared minus 4x plus 7 plus 4x cubed minus x squared plus 7x minus 2. Now we're trying to combine like terms, but what we do here, since we have all these x's, let's look at the x with the highest exponent, which is 4x cubed. There's nothing else that matches up with that, so we will write that down. Now we go to the x squared. There's an 8x squared and a minus x squared, which will give us a positive 7x squared. Okay, next, we have x. We have negative 4x, and we have positive 7x. Negative 4x plus 7x is a positive 3x. And then we have positive 7 minus 2. 7 minus 2 is a positive 5. So that's it for 33. Now, we do need to do 36, and I think 36 is kind of easy. It says choose the one best answer to each question. What is the simplified form of the expression 3a squared b plus 4ab plus 3a squared b plus 5ab? Now, when we look at this, we have 3a squared b plus 4ab plus 3a squared b plus 5ab. Now, we got 3a squared b and 3a squared b, which is 6a squared b. Then 4ab and 5ab is 9ab. So our answer here would be, what's that, B. And then finally, problem 37. When simplified, how many terms are in the polynomial? You have j squared, let me see, you have j squared plus k cubed minus 2j cubed plus 5k cubed minus 2j squared. Now remember, I said that terms are separated by addition or subtraction. So what you do here, this is one term. This is your second term. This is your third term, your fourth term, and your fifth term. So your answer here should be 5, which is D. And that concludes this lesson here. And I will put this up on YouTube. Have a wonderful day.